Law of cosines. The objective is to use the law of cosines to solve triangles. Who uses this? Well, engineers can use the law of cosines to solve construction problems. Well, what exactly is the law of cosines? It's a series of 3 different formulas here that coincide with the triangle you can see on the right-hand side. There's a pattern that happens, and I'll verbally explain the pattern to you. If you're having trouble with it, you can always revert back to just following these 3 formulas and just make sure you relabel your triangle with A, B, C, little a, little b, and little c. So, little a is across from angle A. Side B, little b, is across from angle B. And little c, which is side C here, is across from angle C. Now, just like in previous sections, we always deal with opposite angle to opposite side to opposite angle. You're doing the same thing here. So say you wanted to find the length of A. You would take A and square it, and then that's going to equal the sum of the other 2 sides, whatever they happen to be, squared, minus 2 times the other 2 sides times the cosine of the angle that's across from the side you were looking for. Well, let's see if you can hear it one more time from a different angle. Say you were looking for the measure of angle C. You would use the opposite side here, so C squared, so this opposite side squared equals the sum of the other 2 sides squared minus 2 times the other 2 sides times the cosine of angle C. You would use the law of cosines if you have a triangle with 2 side lengths and the included angle measure, so like side angle side, or if you have 3 side lengths. Let's try practicing this. Take a moment and write down this example. Now that you've had a moment to write down this example, let's practice labeling. So across from angle A is going to be side A. Across from angle B is going to be side B. And across from angle C is going to be side C. So, they're giving you an angle measure, and we would like to find BC. So this is the side we're trying to find, so why don't we highlight that? So this is the side we're trying to find right now. So we're going to take A squared, as it's the side we're looking for, must equal the sum of the other 2 sides. So the sum of the other 2 sides, and we're going to square it. So we have 9 squared plus 14 squared minus 2 times the other 2 sides, so 2 times 9 times 14, and then that's going to be times the cosine of angle A, since that's the side that's opposite what we're trying to find, or angle, sorry, opposite of that side. So we have the cosine of 62 degrees. All right. So we just have to simplify this. So A squared is kind of still all by itself. And then we have 9 squared, which is 81, plus 14 squared, which is 196, minus 2 times 9 times 14 times the cosine of 62. So if you put all of that in your calculator at once, you're going to have minus 118.31. And now we continue to follow order of operations. We add and subtract from left to right, so we're going to add first. So we have A squared equals our 81 plus 196, and then we're going to subtract 118 and 31 hundredths, which will bring us to 158 and 7 tenths. A is not by itself yet. We need to take the square root of both sides. So A equals or is about equal to 12.6. There's no units, so you can write 12.6 units if you wish. Try this next one on your own. Now that you've had a moment to try this next one on your own, let's work on it together. It wants us to find angle R. So we're going to use the side opposite it as what it's equal to. So 9 squared equals the sum of the other two sides squared, and the other two sides are 4 and 7, so 4 squared and 7 squared, minus 2 times those other two sides, so 2 times 4 times 7, and then times the cosine of R. Just like we did in the last problem, we can follow order of operations and solve. So 9 squared is 81, 4 squared is 16, 7 squared is 49, and then here we're only going to be multiplying the 2 times 4 times 7 because we don't know what the cosine of R is. That's what we're trying to find. So we're just going to do 2 times 4 times 7, which gives us 56. So we have 56, and then we'll just kind of rewrite this cosine right next to it here, because we are still multiplying. Okay, so let's continue to make this problem look a little nicer here. So we've got 81 equals, so from left to right we can do 16 plus 49, which brings us to 65, minus 56 cosine R. And no, you cannot combine the 65 and the 56 because the 56 is attached to this cosine of R. You can subtract 65 from both sides, which will give you 16 equals this negative 56 cosine of R. And now we can divide by negative 56. So 16 divided by negative 56 gives us negative 0.29, which is going to be what our cosine of R is. We're looking for R, not cosine of R. So we need to do cosine inverse, because when we're trying to find angle measures, we use inverse. So the cosine inverse of negative 0.29 equals the R that we're looking for. And in this case, cosine inverse of negative 0.29 is about 107 degrees. So angle R is about 107 degrees. 107. That concludes our lesson on the law of cosines. If you have any questions, see your teacher.